How cosmic rays helped find a tunnel in Egypt's Great Pyramid. Humans have spent millennia attempting to unlock the secrets of the pyramids of Giza. Built some 4,500 years ago, they contain tombs and chambers that once held the remains of early Egyptian pharaohs. But modern technology has revealed that the pyramids also contain hidden voids. In 2016 and 2017, a group of researchers known as the Scan Pyramids Project identified several such cavities within the pyramids. And, this week, the Egyptian authorities announced new details about one of voids, the North Face Corridor, which lies just above the entrance to the Pyramid of Khufu, the Great Pyramid, the largest of the pyramids on the Giza Plateau. With the help of a technology called muon radiography, which uses cosmic ray particles to probe objects and construct 3D models of their insides, scientists have confirmed that the North Face Corridor stretches 30 feet long and over 6 feet wide. Archaeologists are skeptical that these empty spaces have any ritual significance. As archaeologist Kate Spence told National Geographic in 2017, and as archaeologist Mark Lehner told the New York Times, research has shown that Egyptians likely built gaps into the pyramids to relieve pressure and keep them structurally sound. Still, like the pyramids themselves, these voids continue to fascinate us. So how do we know they exist, and how do scientists measure them? Here's the science behind the technology. The science of muon radiography. Scientists got a better glimpse of the pyramid's innards thanks to a clever imaging technique called muon radiography, which was first tested in the field at the pyramids of Giza more than 50 years ago. Muon radiography relies on the muon, a kind of subatomic particle very similar to the electron, except it's about 200 times more massive and lasts only a few millionths of a second. Despite their short lifespans, muons are constantly raining down on us. Extreme cosmic objects in the Milky Way and elsewhere constantly produce high-energy particles that occasionally smack into Earth. When these particles, called cosmic rays, collide with our upper atmosphere, the impact produces a spray of particles that includes muons. Earth's natural muon drizzle poses no threat. If you're reading this story on a modern smartphone, 10 muons will have harmlessly passed through your screen by the time you finish this sentence. Muons also have just the right properties to help out scientists trying to see through structures, whether they be pyramids, monasteries, or volcanoes. They pack enough punch to pass through solid objects. And they're also straightforward to detect with special emulsion films and detectors. Crucially, muons pass through empty space much more easily than they do through solid objects. So by setting up a series of muon detectors at different locations and angles within a structure, scientists can map out what's solid and what's an empty void. That's exactly what the researchers did here, as described in a new study published in the journal Nature Communications. Two different teams of researchers, one from Japan's Nagoya University, the other from France's Alternative Energies and Atomic Energy Commission, set up a series of muon detectors within two known passages in the pyramid, its descending corridor, and a passageway dug into the pyramid in the 9th century AD that now serves as the tourist entrance. These detectors were set up to face the previously discovered North Face Corridor. After months of data collection, starting in 2019, researchers combined the different muon measurements to figure out the size and placement of the North Face Corridor's empty space. In all, the void is about 30 feet long, about 7 feet tall, and about 7 feet wide. But while researchers have now obtained precise measurements for the corridor, its exact purpose in the Great Pyramid will remain a mystery to some, and a confirmation of ancient Egypt's well-known engineering prowess to others.